but we don't have really high confidence in that. So it looks like distance from C to A is less than distance from A to C, as we would have expected, but how sure can we be based on this information if we didn't know how we went around the roundabout, if this was just done blindly? Just based on the statistics here, we'd be reasonably sure because of the way these numbers worked out, but I would say don't bet the farm, okay? We're not sure enough to make heavy commitments based on that result. Now, let me point out that there is statistical analysis that we could do, but we didn't have time to develop it. You need a whole course in statistics before you get the idea of just how you would actually get these 90% confidence intervals and so forth. We're just making an estimate and trying to develop a concept of these intervals and how they might be applied. When you take a statistics course, you can get the actual methods, and hopefully you'll understand where it's all going a little better, and you won't lose the forest for the trees, because that's really easy to do in any math course. Another thing is just how accurate do we think this difference is? Based on our analysis, the most likely difference between these ranges would indicate that there's about a 0.005 mile difference, or about 26 feet, between coming in and going out. We'll see that that is clearly just a little bit low. However, that's just based on the middle of each of these ranges. If we look how wide these ranges are, we see that there's lots of possible overlap in these ranges, and the distances could be many times as great as this, the actual difference. And even though this is at 90% confidence, we're not 90% confident of this estimate. If we wanted to be confident of this distance within, say, a few feet, we would need at least hundreds of observations, and perhaps, I think kind of likely, thousands of observations to gain that level of confidence, and we simply don't have that. Okay, now just looking at the roundabout, and things have gotten a little tight here. Look at green. If in driving around the roundabout we come up with a reasonable estimate that this distance is about 65% of the distance around the circumference of the roundabout, and this distance about 35%, and I think that's probably reasonably close, then what would be the distance of the diameter, the area, the circumference, the radius of the roundabout if the difference in these two distances was 26 feet? Well, the difference in the two distances would then be 0.65 c minus 0.35 c, and that would have to equal 26 feet. So the algebra is very simple. Subtract these, you get 0.30 c equals 26 feet. C equals 26 feet over 0.30, that's 90 feet. Okay, now that would be a 90-foot difference in the circumference, which would mean only a 90-foot difference, a 90-foot circumference, which would indicate only about a 15-foot diameter, and the roundabout is a whole lot bigger than that, so this 26 feet was not a very good estimate. I'll say that a rolling odometer, where the numbers keep rolling, okay, and you don't just get a sudden change at every tenth of a mile. You can estimate the hundredths of a mile on a rolling odometer. And if you can estimate hundredths of a mile, that vastly improves our estimates. Okay, it allows us to measure 10 times as accurately, or if we can estimate accurately, if we can estimate hundredths accurately. We probably can't do that, but we can probably get at least 5 times better in our distances, which will allow us to narrow these results down much more closely. Now, there are biases, user biases, that would enter that aren't there when you're doing just the discrete tenths of a mile on an electronic odometer. Okay, on the analog odometer, you get the user has to do some estimating that isn't done on the electronic odometer, and there's a little user bias in estimating. I might estimate anything at the 200ths of a mile a little bit low, whereas at 700ths of a mile I estimate a little bit high. Now, one would think that over 20-some observations, those anomalies would kind of cancel each other out. But that would be another subject of study. Okay, but the point is, with a rolling odometer, we could get much better results, much better result here, and probably we could get results as good with a rolling odometer, an analog odometer, in 23 observations as we could in 230 observations, 10 times as many observations with the electronic odometer. The real impetus behind this whole idea is the nature of measurement and accuracy and precision. And you really want to think about those things as you get into activities and sciences and studies where you're dealing with statistical data, where you're dealing with measurement. You've got to think about accuracy, precision, and think about all the things we've talked about here. And again, hopefully, you'll get a good statistics course, so you'll be able to fill in the procedures that we would use to make more accurate, to draw more accurate conclusions from the kind of data that we have. I haven't done a detailed statistical analysis on the data, so I really, and if I can find time, I'll do that. I'd like to see how close my estimates were, but again, don't take my estimates, don't take the actual numbers seriously. The whole idea of these curves and these estimates and these probabilities and so forth is quite valid, but the details are simply informed estimates and not reliable results.